There'll be a lot of good takeaways here. So we're going to look at the tools, the life cycle, the advantages, and then I'm going to end this with a demonstration. And we should have some time for questions as well. And I know I go right into a break, so I'll make sure I get you plenty of time after that. And then the stack of tools. So let's go over each one of the individual tools that I've already called out. I'm going to skip ColdFusion for sake of, I'll probably bore everyone in the room. You're already on it, but let's start with Divolte.js. So Divolte.js is the front. It's the main engine that we're using to analyze page streams and page click events and any events that are actually firing on the DOM. And it's a scalable performance server for collecting all your clickstream data. It's a very, very small JS file that can sit on all of your pages. It's non-blocking, and it's just a simple tag, and it allows you to do a number of things, including custom events. And it's really the foundational building block for what you're going to see today. If it wasn't for this front piece, you wouldn't be able to do the data aggregation and data collection in real time and start to do those performance changes to your pages, your tracking, and giving your business better insight into the analytics and the users on your site. So a couple of things I want to talk about Divolte real quick. Let's talk about speed first. It's extremely fast, it's high performant. It's built on the Undertow HTTP implementation, and I'll go into that a little bit more detail, but essentially it's non-blocking. So I'm not going to compromise the DOM or the page loading or the page performance at all by rendering this little JavaScript include on every single page request. It gives you the ability to do any kind of custom event you would like. So you can do things from logging events on the browser, firing custom events, using JavaScript, just pure native JavaScript. There's no additional plugins or libraries or any other thing that you need to install. You can do it all just from simple JavaScript. The other things we've been looking at using these for are impression tracking. You can measure when users are zooming in on your products, when they add to cart, when they remove from cart, when they abandon cart. Anything in the DOM is trackable. And we can go into some significant details into the DOM and what you have as your exposure to you as a developer and things that you can pull out and start to make real-time decisions on. And then it uses an Avro schema. So it's a very clean, semantic, descriptive, showing protocols and the actual JSON structure of the data that you're going to collect. So it's universal. Thankfully, Divolte adopted the Avro schema, so it makes it very, very easy for developing exactly what you want to track and then describe that directly through some JSON. And this is it right here. This is all you need in order to start tracking on your site. So a simple Divolte.js file. It's about 8 kilobytes in size. And you can see here, I got some syntax that says defer async. So essentially what it means is it's going to wait till the onload event fires. And after that's complete, then it's going to actually go, so it's non-blocking. So it's not going to hold up the DOM or the rendering or anything like that. And then if you want to fire a custom event in Divolte, it's just calling this built-in function once the namespace is established and it's loaded. I got Divolte.signal, and in this particular case, I'm tracking every search result click, and there's some additional data that you can track. So it's a complex or a JSON object that you can nest with multiple datas, either through arrays or structures. You can do booleans, you can do strings, you can do a number of different data types, and all of this data can be streamed in real time without causing any impact to your DOM or your browser. As far as performance goes, it's network I/O bound. What this means is it's not going to be bound to the CPU. So your CPU will actually go into I/O 8, and then it allows for lots of reads and writes. And this is going to get really critical as you start to grow your site, and you start to grow with the events that you want to stream and click. It's going to it's going to keep your servers moving as quickly as it can. So as you'll see in some of the demos I'll show you a little bit later, it's going to allow for your reads and writes to be very efficient and continue to move through. So in real time, you can modify the DOM and you can continue to scrape data without the user seeing any kind of impact. As far as measurements go, you do about 12,000, 15,000 requests per second per processing thread per second. So this will handle just about any load. I'm currently running this in a production level site, and we haven't even touched the blip on performance, but we're streaming somewhere around 900 to 1,000, in some cases, event streams per second. So it can handle it, it's very quick, and some of these tests that we've performed, it was just on a Linux VM running on a laptop. And if a laptop can power this, it shows you basically on basic infrastructure, you can definitely do quite a bit with this simple JavaScript library. And then HTTP Undertow is just a Java web server based on non-blocking, and it's lightweight and it's a high-performance web. So this whole thing was built on Undertow, and that's what gives it a lot of the flexibility under the hood to do a lot of different processing and connection to other platforms and tools. So the second thing we're going to look at is we have Divolte.js first. That's the JavaScript Collector. And then the second one is Kafka. So Kafka is used to ingest all kinds of data sets. It can go from databases, from applications. Think of it as like a RabbitMQ on steroids. It's a messaging platform. So it allows you to publish to Kafka, and then you can have multiple subscribers. Essentially, it allows you to do high data streaming or processing with very, very low latency. And then you can also start to create these Kafka topics, and you can use it for other subscribers. So say if you want to push it into S3 buckets for cold storage, or you want to use it for other alerting systems, or you want to push it to third-party applications, there's a lot of potential for Kafka in order to do that. So a couple other things as far as the buffering. A lot of jobs or a lot of companies or a lot of sites you'll see where they have to run nighttime jobs. You have to process a lot of data in types of batches. Kafka allows you to remove that from your infrastructure and take a lot of load off your application servers. So you don't have to run big jobs through the night and then try to predefine that data or aggregate it in some sense and then push it back out to publish it. Kafka allows you to do this behind the scenes and takes that load off your main application servers, especially if they're web facing. And also you can run it on its own independent cluster. So it really truly is completely independent. It has an autonomous state to where you can just push to it, push to it, push to it. And it has a lot of potential to aggregate that data for you without putting any load on those application servers. And it also is real time. And I'm going to give you some timings from the time when I actually invoke a web page. And I'm going to show you some real-time logs and how fast Kafka can actually process the data through that Avro schema. And also, it centralizes your data for you. So you can build out topic after topic after topic in Kafka. So it doesn't matter what tech stack you're on, whether you're ColdFusion and you got Java folks or Python folks, and all technology stacks can push into the Kafka topic. So it has a lot of potential there and gives you the ability to stream out as needed. So you can have one producer and one consumer. So thinking of it as pushing into one big bucket and then multiple subscribers that can go and get that data out when they need it. It also low latency, so the data points can process and let about right around 10 milliseconds. It allows you to horizontally scale, and then it allows you to spin up as many brokers as you want. But the brokers are essentially just the Kafka term of service. So a lot of opportunities here with Kafka. All right, so Druid. This is going to be the query layer. This is essentially what powers that real-time personalization. And what Druid is, it's just an open source analytics data store, and it allows for a lot of different functions, especially for business intelligence, for running real-time reports, influencing the page, querying your data. Right now, I think in one of our Druid segments, we've got around 75 million segments. I can do queries and return data back in a top-end fashion in less than about 15 milliseconds. So it allows for really, really fast aggregation of data, allows you to process and form that data in different types of payloads and responses, and then you can scale up to trillions and trillions of events. I'll let you know if I ever get there, but it is supposedly can handle petabytes of data. So it's built for scale, it's built for speed, it's really meant for real-time aggregation. Think of it as that way. It'll allow you to go in with a few dimensions. We'll talk about some dimension queries here shortly, but you can chain dimensions and very quickly get back results. A couple of use cases for it. You can analyze event streams. Maybe you're trying to track and monitor errors flowing into your sites, well, without having to put any kind of load on your application servers. Druid can start to analyze performance of your sites, can catch errors, can inspect those errors and start to do things for you, whether it be warning back to your own admin systems, or it can start to shut down parts of the page if it determines that there's a problem. It can check for performance issues and throttling rates. It has a lot of possibility. And it's using that OLAP type analytic database, time series type databases. It allows you to do that online real-time analysis of data as it's streaming in. That's what it's meant for, and including batch data. So if you're batching data into, say, Kafka, and then you want Druid to subscribe to it, Druid allows you to parse those data sets very quickly and then return responses for whatever the use case may be. And the nice thing about Druid is it integrates directly with Kafka. So as soon as Divolte collects data on the DOM and starts to stream it and push it into Kafka, Kafka and Druid have a direct connection. So you're able to stream directly from Kafka into Druid. Now I'm doing some pre-processing with NiFi, and we'll touch on that just a little bit, but NiFi is sitting in between that layer and it's doing some scrub to the data, performing really an ETL on it. And it's just doing a couple different things that we need that are more specific for our use case of actually personalizing pages. But Kafka can directly connect to Druid, which makes it very powerful. So from the time the web page is starting to render and the time the data is available in Druid, so it goes from Divolte to Kafka to Druid and available for query on the DOM, that total round trip time is about 15 milliseconds. So as a user hits a page, and I've got the above fold experience, I can start to manipulate everything below the fold before the user even sees the bottom of the page. And that's actually looking at the user, who they are, bringing back very personalized data sets of that user, and starting to manipulate the page in real time, so it's truly customized for him. As far as internal use for BI reasons, it is good for like ad hoc type of analytics. So if you have a marketing team in-house or you have business owners that need to see data reports, instead of having to generate those reports and wait for them to process, ship them out, or maybe there's a delay on how fast you can get it to them, users can watch real-time streaming events as they occur. And so Druid is as far as Druid goes, it is a query layer, but there are a lot of different tools that you can wrap around it for a good UI experience. We'll go on that in just a moment. So for a business owner that might not be as technical, they probably don't want to go directly to Druid, but I'm going to give you a use case for Superset that should help tie that knot in for maybe your non-technical users. If you're streaming this data for business reasons and you want to be able to share this data for marketing reports, there's an option. And you are here being engineers, you probably want to use Druid directly because it's much faster and easier to use, especially if you know how to write a SQL statement. But I'll show you both to cover both angles. And also, it can be deployed anywhere. I'm running this on-prem right now, but it certainly can go into the cloud if you wish to do so. So there's a lot of flexibility on how you want to use it and implement it. So I want to talk about the UI visualization. I just touched on it briefly. You've got Superset also plays very nicely with Druid because it has a direct connection. So you can, just as simple as creating a data source, you can actually go into Druid, you can get the data sources of Druid, and you can actually connect it directly to Superset. Superset was created by Airbnb. This is what they use for a lot of their real-time reporting and their analytics. It has since been pushed into the Apache landscape, and it is in incubation. So obviously, it doesn't necessarily mean it's going to make it through as a completed Apache project and supported, but I do believe it's pushing down that path. It seems like it's getting closer and closer for approval. There are a lot of big Fortune 500 companies that are using Superset to analyze data sets, do BI, do reporting for their business needs. And the wonderful thing about Superset is it's completely open source. So one of my goals for these tools and selection was to keep the budget as low as I could, and the budget was at $0. Everything we're seeing today is open source. There are no requirements for enterprise licensing. You can use these at will. I think there is some different support companies that will offer consulting on it and things like that. But as far as what it would cost you to get this stack up and running, outside of your server costs or your infrastructure costs, yeah, actual applications of Divolte, Superset, Druid, and Kafka, there's going to be no costs. So completely open source, what I'm showing you today. There are products that retail for $350,000 plus to do a lot of these. You can use Tableau. You can connect that to Druid if you wish. There are other, obviously, UI tools on the market that you can connect into Druid with. But for the sake of money, if you're looking for just a POC to get something up and running, all these tools are now supporting around 67 million segments, and I'm pushing about 2.5 million segments a day through the product. So it can handle the scalability. That's on a decent amount of traffic. I've rolled this out on a few sites in our production environment, and we've already seen a lot of benefits out of it and starting to control the UI and do a lot of biometric type fingerprinting to a degree just to make sure we're giving the user the best experience that they can have on our site. You have a lot of different options with Superset. It has pre-built charts, so it has heat maps, it has directional, it has tables, it has pivot tables, pie charts, sand keys. Everything you can think of in here is pre-built. And if you do have a subscription to like Mapbox, or if you're using any other kind of geolocation lookup, a lot of it has built-in API. So if you want to have a map of the United States up and see your real-time traffic and what people are doing on your site, which pages they're hitting, what are they adding to the cart, you can actually put this up and then use Druid to feed that data into Superset. So it gives you a real-time look at how well your sites are doing. If you want to see where errors and pain points, bottlenecks, breakdown of how many people have a shopping cart, what's in the cart, how many removals, you can watch abandonments, all you can do that and you can visualize it directly through Superset in real time. The latency is about less than a second. So by the time the user is finishing his rendering on his DOM, you're already seeing that data in Superset, and you can make quick decisions based on that and move forward. So there's no delay, there's no wait, there's not a 24-hour-old stale report that you get. This is all real time. And the nice thing I like about Superset is it offers SQL syntax. So even though the Druid data is in segments and it's in a JSON schema, Superset allows you to go in and write direct SQL statements because Druid supports direct SQL statements. The syntax is slightly different, but overall, you get the picture here. I've got a simple select statement, and when you see here where it says search underscore term, all that is a dimension. So think of dimensions or any attributes or data points of your site. Say if you're up and you have first name, last name, you have search terms, you have product IDs, total shopping price, whatever the case may be, each one of those data points can then be chained and queried on. So you don't have to build service after service to get data out of it. So you can build one query and you can customize that query dynamically, and you can start to chain these dimensions together to give yourself very detailed reports. So if I want to know right now on all of our sites, and we're international, we're in 9 different countries, if I want to know what the most popular search term is, I can go ahead and run this, and in less than a second, I know what's trending around all of our sites around the world. If I want to break it down into a site country, say USA, I add one dimension in that to say, I want the search terms and I want the site country equal to USA. I now can see what's trending in the USA. And then if I want to get very specific, I can say, I want to see what my users in North Carolina are searching for right now. And I can break it down. So think about this. We're so specific now with what we can tell. If I've got someone who's in Las Vegas who's on the site and they're doing searches, I can make it more relevant for based on where they are, especially if it's an e-com or maybe they're looking for something to do, a business to go out and eat, versus North Carolina. By looking at geo lookups and IPs, I can start to triangulate, figure out where they are, and I can start to make it a more specific search. So the point here is you can go as global as around the whole world and see how things are trending, or you can get good data points and feedback on how well your sites are performing, but I can go as granular as a user, even down to the geography of where they sit. And all this, again, can be chained and done in real time, and you're talking absolutely just a handful of milliseconds to get this data back. So if you chain a lot of dimensions, that necessarily doesn't impact your speed. If you do change the interval, you might see a bigger one here. You see this time frame right here. I did October the 1st through October the 2nd. That was returning in about 10 milliseconds. If I pumped it out to maybe about 4 months, it might go up to about 15 milliseconds. So the increase in segments that you check you will see a slight performance change. The nice thing about Druid is, if you write an interval that goes back 1 year, and the first data set that matches is found maybe 3 months ago, it will automatically change your next interval and cache it. So what that means is it'll actually improve the query for you in subsequent runs, and then this will also cache for 30 minutes. So I can continue to refine that query, and the more I interact with it, actually the better the performance you get at Druid. So there's a lot of native things built into it to help with speed and performance that you might not even be aware of, but it's doing that for you under the hood. So Druid's a temporary in-memory database. It will hold on to that data for 30 minutes, and you can change those settings. But the rest of the data is all being pushed into an S3 bucket for long-term storage. So there's a lot of data modeling and some data science type stuff that we're going to be doing with this additional data that we're collecting through using this setup. But as far as a real-time personalization engine, I don't want to run complex calculations and model data for a user to sit there and wait for it to calculate. So the same data that we're using for our data science movement and research and modeling, it's the same data that I'm pulling from. It's just Druid allows me to keep a temporary block of data and then automatically connects to S3 buckets and pulls that data out and allows you to move through and make calculations. And it works with Hadoop. It works with a number of other options and technologies. So a lot of these tools have gotten to the point where they're plug and play. So you're not tied to these technologies that I'm saying, but a lot of them do have a lot of crossover and support capabilities across multiple technologies. So I'm going to show you a quick lifecycle request to draw it all together because I know I'm throwing a lot of information at you. So at the top left, I've got a couple desktop setups there, client machines, and I've got a couple tablets and mobile devices. So you can see the include at the very top. I've got a script source of external Divolte.js and defer async. I showed you that earlier. That's all that's needed to get the Divolte engine running on your site. And as soon as the request comes in, it's an asynchronous tracking event that's fired. So as the user's moving around on the page, I'm starting to track that data. And I'm going to show you some other things with velocity and X and Y coordinate graphing. That's going to show you how you can actually do like a biometric follow or a fingerprint of the user. Because I'm able to stream that through Divolte as well to start determining what kind of user I have on the site. So an asynchronous event fires. It goes through our load balancer. I've got a 3-node Divolte cluster that sits on the back end. This is the Undertow environment, or the Undertow HP and servers that sit behind for the streaming and the collection of the data. That's sitting behind a load balancer that is optional. You can go directly just to one if you want, but this is built for scale. After it gets into Divolte Collector, it will go through a process of a direct connection into Kafka. So I have 2 topics in Kafka. I've got a raw topic and I've got a clean topic. The raw topic takes all of that DOM data and all that event data and throws it into a Kafka topic. Now there's a number of things I can do at this point. I can push that into S3 directly for my data scientist. I can also do a scrub on that data or an ETL. Now, some of the data might have some bad characters in it. It could be malicious. I might want to check it for something, or there's something I want to get ahead of even faster, maybe for monitoring reasons. And that's where NiFi comes in. This was a product developed by the NSA. So it's probably listing everything we're doing. I'm assuming there's probably more to it, but it is open source. And it's a great ETL. And there's other options that you can use for this, but NiFi, again, is great because it's free. And it does a really nice job at doing processing on logs. So you can do a number of things with NiFi. You can take the data in, you can pre-process it, you can post-process it, you can scrub it, you can break it into CSV files, you can break it out of JSON format, you can do API calls from NiFi. You can take the data and push it into SQL, you can take the data and push it into S3. There is virtually no limit with NiFi and what you can do with raw data coming in. So in this particular case, we're using NiFi to scrub the data. And then that NiFi agent will go ahead and post directly back into Kafka. So NiFi has a direct connect into Kafka. And what that means is I can take that raw data, that streaming data, push it directly back into a clean Kafka topic, and essentially I've now prepped my data for real-time personalization. So after that data goes back into my clean Kafka topic, 2 things happen. My raw data pushes into my S3 cold storage, and my new clean data also pushes into the raw S3 storage. Now the raw data can be used for maybe data science modeling. If you've got a scientist in there and they want to do raw data analysis and they want to use it to help build models, that might be a good fit. The clean data that I'm pushing into S3 is used for historical analysis. So if I want to do a personalization run at some point that goes back 6 months, S3 is a great unit for storage because I don't put the overhead on Druid to get it out. It goes into S3 and then Druid's able to go directly back to S3 if it goes outside of the interval that it has in memory. So from S3, I push right back into Druid, and Kafka also pushes into Druid. So I have 2 options to get the data into the Druid, which is my query language or my query environment. And then Druid's kind of the center of the personalization world for me. That feeds Superset directly. It also feeds Tableau. We've since added Tableau as an additional reporting engine for the business, but Superset's kind of the quick and dirty free version if you want to share reports and generate reports. We are using Tableau, can go, like I said, Tableau can go direct connection to Druid, and you can always use Druid directly, and I'll show you the console for it today. But that's also an option for querying and getting data out. And then that round trip comes right back out. So if you see the arrow that goes back out to the DOM, it doesn't technically connect the devices, but you can see where it points back to the script tag. What that is saying is that now Druid can serve data directly back to the DOM. So as somebody hits the site and I want to start to personalize it, that whole round trip process is about 30 milliseconds, about 20 to 30 milliseconds. So as soon as the user starts to invoke that page, this whole round trip to get it back onto the DOM for influencing, you're looking at about 30 milliseconds. And I'll show you some real-time stats and API calls that we've got running today. So one of the use cases, we have search terms. It tracks the last 5 search terms that you made on the site. And what this does is, so without having to write new databases and new APIs, we're able to write a simple query in Druid and expose it through the API manager. And that API manager is sitting in an AJAX call in our DOM. And I can sit there as the user starts to search and type. I'm firing off events when they complete the search. We push it through this whole stack, and it comes right back out, and it's kept on the top. And that way we can actually influence the page. So I've got search terms that I'm keeping, as I said, per user, per country, and per the whole site. So we can do trending, Other things, we can start to manipulate the page based on search terms. If we know a search, and we can also track, say if a user does a search, a lot of users are doing a search term on dog food, and we know it's trending. If the users are going to start searching for dog food, we can start to give them easier carousels at the top of the search page without them having to troll through results. So we can actually highlight products that we want to focus on. So we can determine that based on what the user is doing, we can also determine those search results and how many of them ended up in an invoice or a checkout order. And those are obviously popular products, and we can take that aggregate and the search term aggregate, and we can build carousels on the fly for the user. So it saves them from having to scroll, dig through search results, get frustrated. We can predict based on analytics what people are searching for and what they're actually buying, and start to influence the page in real time. So a couple of advantages here I'll show you. Basic stuff that you can do right out of the box. You can obviously get very creative with this setup and come up with some ingenious ideas on what you want to use this for, but you can tell where they're coming from. You can do if they're organic versus paid, or I know our marketing team is very interested in this for email tracking, so they're going to send out 1 million email blasts. We can start to actually watch the email transitions on our site. They came in from the email. We can track that whole experience. We can tell where they're getting lost, confused, they're checking out, not checking out, or moving through what their behavior is. So all that can be now easily tracked in real time without having to generate reports or slower reports that normally would happen, so at least a 24-hour delay. We can also push them in a certain direction once we know where they're coming from. Maybe it was a specific email campaign around a certain product, but we can maybe help push their experience on the website to a more funnel spot versus with them having to go around the site and try to figure out how to get to what they're actually looking for. Most popular products, pages, sections. We can do historical, real time, search terms, metrics, and routing. What are they engaging with on the site? What are they viewing? What are they purchasing? Did they abandon the site? We actually can get to see if we have their email and contacts. We can email follow up, say, hey, you left your experience, you didn't buy. How about a 20% coupon? There's a lot of potentials here. You can track conversions, removing products, updating products, abandoning their carts, whatever the case may be, and all click events, time spent, and Markov modeling for site traffic. Now that's getting into more of the data science, but one thing I want to touch on, the Markov modeling is very interesting. I don't know if you've ever seen where you have an XY graph, and you might have like a heat map, and you'll have dark spots, and you'll have pages on the X, and pages on the Y, and pages on the X. And you can actually see what the propensity or probability of them moving from one page to another. And what it's starting to show us is, if users get into a sequence where they go into 3 or 4 pages and that click sequence is the same as a lot of other users, but it seems like they're going back a lot to get to another page, we can cut out the bloat of the navigation in real time and know that if they're starting on page A, they're actually trying to get to page D, but they're having to go to B and C. We can actually remove that in real time and just get them directly to D. So it's getting to where they need to go faster. This all can be processed and analyzed in real time to give each user a better experience. Quit the confusion on the site and get them to where they need to go, get them off the site and let them finish what they need to do without any hesitation or distractions. When we looked at this too, we kept thinking there's obviously a lot of ways for personalization, but one of the other interesting use cases is metrics. What this is allowing us to do is check for like things time to first byte to the page, which is a big measurement for speed. And it has started to improve a lot of the performance tuning that we're doing on the site. So it was before where someone said, hey, the page X is really slow. And, we go hit it, we have our dev tools up, and we're like, no, it's not. It loaded extremely fast. Yeah, we're one instance, one thread. Who knows what time of the day it was or what process might have been running. What this allows us to do is we can monitor the time to first byte in real time. So if we see a big increase in a page, we quickly can know before anyone else does. We can get notified. We can identify a potential problem or an issue. We don't have to be awake and watching it, and we don't have to worry about trying to go invoke it directly or recreate it through some type of a load test. We can monitor all these metrics in real time because everything in the DOM is measurable. The personalization, which I'm going to show you, that's another nice feature of it. But the performance alerts and errors and exceptions, that's been a big help. And what that allows us to do is we can track everything down to where users are having slow, painful spots where we get errors. We can gracefully start to handle degradation of pages. Like if we know that there's a particular service that is having issues, we can start to shut those things down automatically based on analysis of real-time click event streams. So we can start to maybe help the user get through a painful spot. Maybe we might have a particular issue on the page that's rendering a bit slower, and it allows us to start turning things on and off on the page in real time so that the site performs as best as we can. Again, you might have a degraded experience from what they're seeing, but the good advantage here is that they're going to get through it. They're not going to hard error out, get frustrated, and leave your site. As far as personalization goes, and this is, I think, a particular way that you can look at. Maybe this is going to be more focused if you're looking at monetary ways to exploit this, to start to use it on your sites. But top-end queries can be called utilizing direct REST APIs. So that's the big bonus of Druid, is it has every single function of the query is exposed to a REST API. And this allows us to go directly into that Druid layer, get data out, and then influence the page. So it also can be done directly through a SQL call, but you have the ability to do a SQL call through REST API, and you also, or SQL syntax through REST API, and you can also do JSON notation as well, or JSON object through the APIs to get the data out of Druid. Allows for that real-time manipulation of any page, and then customization of pages based on the user's behavior. And then also you can get into the report. You can start to do reporting based on users' clicks and interactions. One of the more useful things to know is, did somebody see something? So say if you have 10 carousels on the page and you want to know how effective each one of those carousels are. Maybe you have a stack of products in each one, and the first 2 carousels have 350 hits, and then there's one at the bottom of the page that only had 60 hits. Well, if you look at the numbers directly, you're going to assume that the other 2 carousels are more impactful. But the problem is you don't know if the user actually saw it. So you can use Divolte to start to see what people are seeing on the DOM. You can start to say, if this element comes into view, send it as an impression. If this element comes in, see it as an impression. So that way you can start to look at your click interactions and your impressions, and you can actually determine what is working percentage-wise better than the other thing. And you can start to manipulate or destroy the carousels that aren't working well, or maybe even combine multiple products and multiple carousels and put it into one carousel and save the overhead on your pages and your speed, and make it very simplistic for the user to find what they're looking for. A couple other things you can do with this. Right here, what I'm showing you is a velocity tracking of cursor movements. So with using Divolte, you can use Divolte to stream this data in. And why this is important is this shows you cursor movements of your users. And if you're getting into fraud detection and things like that, for a bot, for example, bots are going to go directly to whatever element that they're trying to find, right? There's going to be linear or straight lines. For the most part, they're not going to deviate. The cursor movement is going to be very sharp and angled. And it's also going to have a more consistent velocity. So what this is measuring is every time I move the cursor, whether it's through a mouse movement or trackpad or whatever the case is, this is tracking the speed. And you can actually, over time, start to build up models of your users, and you can see irregular movements of a user. So in particular around a login page, if you start seeing very, very sharp or a velocity that's abnormal for your usual user that logs in, you can start to make some assumptions that maybe you might have somebody logging in who should not be logging in, and you can also determine if it's a bot trying to get in. So all this can be streamed in real time via Divolte, and you can start to do real-time analysis and fraud detection by using this JavaScript library. And one other thing I wanted to touch on this, this also allows you to monitor elements and actually curvature of the cursor movement, because you can also track the XY coordinates. You can take the velocity and the XY coordinates, and you can actually draw out a path of the movement of the cursor. So whereas different people have different movements, and I ran a test with this with my wife, but I had her navigate at the stop, like maybe a menu item on the top left, and I had a button at the bottom, and I said, I need you to move that cursor down to the button, and had her do it about 50 times. And it was eerie how the movement of the line graph, it was the same curvature every time. There was no go this way. It was always the same kind of rounded, non-direct way to get to that button. And I tried it, and mine was more of a straight line. And then I ran a bot against it, and it was just perfectly a straight line from element to element. So you can start to detect abnormal movements by users, which is quite powerful if you're trying to struggle with some fraud issues. And as far as getting the data out, I told you earlier that there's REST APIs to interact with Druid directly. I just gave you a quick, this is just a kind of breakdown using the dev tools to show you an interaction. This was me using the REST API to go and get the last 5 search terms of my user. You can see how it returns a nice clean JSON payload. And this is a customized nodes based on my use case, but the point is, it's pretty much open. So your REST APIs can do as you please. You can start to write these queries, and then that way you can use Ajax to interact directly with Druid, which you have a lot of potential to actually execute these in any form you want, any dimension you want to get data out. And I'll give you a couple more demos. This one might be hard to see, but this is from our API manager logs. Yes, I have to give an obligatory call out, shout out to the API manager, Adobe's API manager, but we're using it in our production environment, and all of our Druid queries are going directly through the API manager. So here's just a couple samples of the logs. This time right here, this is the last 5 keywords. The response time is 132 mils. That includes some additional overhead with a couple of other refactoring things that we're doing, but that's a real API call into about 70 million segments. And that's total time to do an aggregate dimension check on search terms by a user. So it's probably one of the slower type queries you would do in Druid, and that's still returning in about 132 milliseconds total time, including some aggregation happening on our application server in CF. So it's extremely fast. All right, talk about personalization. So top end, it gives you an approximate query. It's all dimension based. So I want to know the top searches. I want to know the top pages. I want to know the top products. Very, very simple syntax to write, very powerful. It allows you to do widgets or carousels or interactions with that page. It has increasing thresholds. So based on a top end query, just say if you're going to go over 1,000 items, the first 900 are going to be about 100% match. You will get some deviation after that 900. So the higher the amount of items that you're actually scanning, the higher the base of the match. So keep that in mind if you're doing a top end query. The increasing threshold will continue to yield better results. Great thing about the page personalization, what I'll show you here in a second, is it's non-blocking. It allows you to control things below the fold, so things that the user doesn't see, and then also some biometric behavior. The other thing you can get into, which I should mention on here, is I call it opportunistic JavaScript loading. So you might have 50 JavaScript libraries or CSS files or potentially things that you're having to load for your page to render. How much of that JavaScript is needed to see the top part of the page? You can start to break down what is required and what is not, and then you can use a lot of this to start to preload or post-load after the DOM is rendered. So you can offload all that overhead to the DOM and decrease your time to first byte, and then you can use a lot of this JavaScript to determine who the user is and start to bring in JavaScript libraries as you need them. So it saves a lot of time and speed, especially Ajax calls that might not be cached. You can defer those Ajax calls based on the user if it's needed. After the page is finished, let them see everything above the fold, let them start their engagement with the site, and as they start to scroll down, start to bring stuff in. So it allows you to do that, monitor it and track it, and just give your users a better experience and also increase your performance of your pages. As far as reporting goes, great things like impressions we talked about. Did the user see this? Did the user not see it? Did they scroll back to it? How much time did they spend on it? Were they engaging with it? Did they roll off it? Did they click on it? All that's handled. XY movements. Everything's got an XY coordinate that you can track. And then also velocity of the user. Again, some of these might be more for reporting and fraud protection, but it also can be used to determine what your users are doing and what they're not doing. All right, so demonstration. So we're going to start off with just the Druid console. Let me try this in. Okay, so what I have here is just some very simple syntax. This is what the Druid console looks like. So this is one way to query it. With everything, you get an interface like this. It allows you to write direct SQL in. You can look at your segments. You can look at the data in there. There's a couple different things you can do with your nodes. You can monitor health. It's a real basic syntax, real easy to use, and pretty much gives you everything you want to do. So if you're more of a technical person and you have the ability to write SQL, you can go in here directly and you can go ahead and construct your queries as need be, and then you can simply hit run. I'm going to do that here. You saw how fast that just returned. So DOM's more of a problem actually trying to render it than how long it actually took to run. So what I just returned back here was very specific search terms based on a particular user, and the interval was from, August 1st to October the 2nd. And if you look at my timings below here, you have to see it. I'm hovering right at 308 milliseconds. And a lot of that is actually the overhead of the DOM trying to render this. If you go directly through the REST client, you're going to see times hover around 20, maybe 30 milliseconds at most with this amount of data. All right, let's do the next one. So that's Druid. All right, so we'll take a quick look at Superset here. All right, so So what I have right here is just the Superset interface. So Superset does a number of things that helps your users out. One is that you still have the ability to write SQL directly in. So the same thing that we just did in the Druid console, I can also do with Superset. Superset's going to do a better job at visualizing it for you. You can start to do things like chart it and graph it and have a different representation. But the same thing applies. What Superset's doing is it's taking this and has a direct data source connection over to Druid. And it's going to run the same query that I just ran. And the nice thing about Superset is it gives you the true Druid timing. And so what it just returned back is a subset of the data that I requested. And you can see that took 0.56 milliseconds to query that search term and bring back all the results. And it gives you a nice breakdown so you can see it even handles double byte characters, non-double byte characters, but this is doing essentially the same thing. It's going in, it's finding the search term, it's searching against an interval, and then you can start to do normal SQL type statements, describe the data and do as you wish. The next thing I'll show you right here is the charting. So right here you have a little different view. This is going to be the non-technical view, more or less. This is what I would imagine maybe a technical person that's looking, or a non-technical person would want to go here and take a look at the data. You have a couple things up here at the top. You can choose your data source, and then you can also include the type of charting that you actually want to do. And the nice thing about this UI is it gives you a very intuitive way on how to break all the data apart. And will actually give you all, once you create the data source, it will actually give you all the data points that you have at your disposal. So you don't have to know the schema of the key or the dimensions. You can come in here and it'll start to give you all the hints to help you write the query. What this also does is it will build a SQL query under the hood. This is making a REST call into Druid. That's all it's doing. So it's just using the same process that I just showed you earlier with the API. This is actually just running a REST call directly to Druid to get the data back. It gives you your time series, your group by statements. You can include time, ascending, descending, everything's in here. And I think one of the nicest features about it is you can come up here and you can actually pick your visualization type. And what this will do is it'll start to go through and it'll give you, the Wi-Fi here is not great, but it'll start to give you examples of each one of the charts that you have at your disposal. And this thing's going to render here in a second. But line charts, big numbers, DECGL scatters, the grids, data dual lines, all this will be pre-built. And if you select any of these charting types, it will actually help you pre-build your query. So you have to have almost virtually no programming experience. Again, a wonderful tool if you have a business or team member that might not be as technical. You do the job of getting the data and you let them play with it. You just push it off and Superset will allow them to interact directly with it. And I'm going to show you the use. This is the this example here. I'm going to show you So I made two REST API calls. You'll see the endpoints going directly to our API manager. So we put the API manager in front so we can do reporting and analytics and monitoring of the performance of it. And then behind the scenes, this is just nothing more than a proxy to get to the REST endpoint in Druid. And what you can see here are 2 times. Again, the 699 is not the true time of what Druid took. There's some other aggregation that we're doing in here and monitoring and logging. But I ran it the first time and I saw a performance of 699 on milliseconds, which is still not bad for going across 65 million or so segments, maybe around 70 for this case. The second call I ran is much faster. You notice it went down to 215. That's because I opened up a bigger interval and Druid went into S3 and it got the additional data sets that it needed. It brought it back into memory. And now all the subsequent runs of this are going to be cached for 30 minutes. So it removes a lot of complexity. And as far as the Druid timing goes, what we've seen is, in this case, just say depending on network traffic and everything else, maybe this initial query took around 30 milliseconds. The subsequent queries after that, after it's cached, we're seeing sometimes as low as 6 and 7 milliseconds to come back. And that's a real-time engine. So you can imagine how fast that is and how you're able to start to manipulate. You're able to start to manipulate the bottom of the DOM, just mostly because of the speed and the fact that it's non-blocking. I'm going to log in here and show you just a couple more things. One thing I'll show you here real quick before the analytics load. This is a site that we're running this real-time query on. You can see the breakdown of the dev tools, the actual endpoint down here, the measurement of it. So this was the real-time Ajax call on a page that we have internally. And then you get the breakdown of the times, but this is the actual Ajax request. You can see the format of the API, and then you can start to see the breakdowns on the times. Extremely fast and easy to integrate. So this was actually influencing that top search bar. So we're even able to take that data, influence even things above the fold in real time. So as soon as I enter a search term, it's going to start to follow me and keep a history of my search terms and actually start to populate the search bar in real time for me. And I can also look at it for trending as well. So if I don't particularly want to just isolate an individual user, I can do it, say, by country, or by likelihood of them sitting in a particular location that's similar to other folks. And last thing I want to show you are some performance metrics. So what we have here are some metrics of, this is the API manager, Adobe API manager. And you can see here's us monitoring this direct Ajax interaction with the REST endpoint. And again, we've got more insights. So now we've got insight from Apache all the way down to the end of the request. So we've got a lot of details. We know exactly the workflow, how things are behaving. But you can see here that the timings are excellent. So these are actual logs of the performance. And you're seeing obviously sub-second times. You got a couple hundred milliseconds at worst case, a few of them. And then you see quite a few of them are, what's this one right here? I think it was at 138. There's 230, 148, 126, 140, 132, 149. That's total overhead. And that includes a millisecond or two from the Adobe API manager at best, at worst case, maybe a couple milliseconds of overhead of passing through that proxy. But overall, that's an extremely fast performance time. So the point I'm trying to drive home is that you can get to the point where you can influence the page to significant detail, including any kind of dimensions on your users, or without creating a blocking situations where the DOM's going to lock up or the user's going to feel like the site's just hanging and that won't actually load. So, we've covered a lot. I'm going to leave some time for questions, but in a nutshell, this is just some use cases for personalization, monitoring and influencing your pages. Any questions?
I guess at what sort of like scale organization do you think it would be useful to like implement all this to it?
So what scale of an organization would be useful as far as how big and so you should use it, or? I don't think there should be any limit. I think even if you're a one-man shop and you're looking to monitor a site, there's no limitation. And I think the amount of data that it would provide you would be useful in any context, whether you're small to large, medium, whatever the case may be. So, does that answer your question? I know it's important to give feedback for all these speaking sessions, so please use your app and give feedback so the organizers can help use that to curate content.
Do you have a link to the presentation?
I'm sorry?
The presentation, do you have a link?
All of them, all these will be shared. They always share all the presentation decks. And I think, when Meyer, they recording all these, right? Are they going to be published, do you know?
Recording, I don't know, but presentation next will be shared.
Presentation decks. And the decks will be. So.
Like, a question, so you're capturing all the data for the talks page. How do you start capturing data for web-on policies? Does it have to be cloud-based? Or would you have facilities for basic apps, basic React apps, something like that? Could you also collect data?
Yes. Yeah, so the JavaScript out of the box for Divolte is going to track a number of things automatically for you. So it'll do IP, it'll do user agent, it'll track the pixel width or the viewport size. There's probably and it does actually a really nice job at parsing the user agent for you cleanly. So it breaks it into multiple columns or data points, so you don't have to have that. You don't have to process through the garbage that, or semicolon, and there's a bunch of verbose things in there. There's about 20 to 25 data points or so out of the box that it will automatically track. And one of the things that we'll do is it'll tell you if it's a mobile device or not. Tablet, the format, it'll actually give you the iOS, it'll give you the type, it'll actually start to classify it as a fingerprint. So it'll say IP, Windows, or whatever, iPhone, give you the size, and it'll give you the iOS as well, if it can give you questions. All right, well, thank you very much. I appreciate your time.